Hello, everyone. Thank you for being here. I know it's the last day, and I know many of you are interested in so many other talks. So thank you for being here. Um, so imagine you're the operator in a control room, and then you start seeing your computers are just randomly restarting, putting in a endless reboot without knowing what's happening, right? So you don't know what is happening. You know seems that this error is coming from a driver, but it doesn't seem that it comes from a known ICS malware or an EDR. Rather, this comes from a file system operation vulnerability. So what is a file system operation vulnerability? It's basically when you have an elevated privilege process trying to access or operate in a file or folder that lower user privilege can have access to. So the most, everyone should know already, is the phantom DLL, DLL hijacking, all those kind of variants in which you can replace malicious DLL and rename it with the name of a benign DLL, and you're gonna execute code there, right? So that's the most known one, but however, there's other things that are also as dangerous, such as creating files, moving files, deleting files, and these operations can lead you to denial of service, information leakage, or even system. Since these are logical vulnerabilities, even after code refactoring through different architectures, that vulnerability is gonna still present. So general landscape, as you can see, is most of this was known to be present in many antiviruses, in many EDRs, because those kind of systems, they need to run with a high privilege so they can access all your folders, all your files, regardless if you have privilege or not. So if you have a malicious file in your system, they can have access to it, delete it, or quarantine it. So they require that high privilege access. But if you look the image on the left, it's not just that. This is not just antiviruses or EDRs. There's also all sort of things like databases, different kinds of engines. So something that writes a lot into temporary files is what is going to trigger these kind of issues. So let's try to have this study case in mind. This is an alert manager that is present, or we identify that many engineering workstations run different kind of monitoring systems, or sometimes SCADA servers are running these kind of alert managers in which they are monitoring the logs that are generated by PLCs, and then based on that information, they write a log, or they can send a message or take an action. So in this case, we have an alert manager that is looking into a configuration file, which it's going to write the operation into a legit log file. However, if you are able to replace it or point it to a critical binary, then you're going to be corrupting that critical binary. So static analysis might know the best solution for this. You lose context. And context here is the most important thing, because you need to understand how is this process running. And since these are very complex logic operations, writing a template in which your static analyzer can identify these issues is going to be really hard. And automated tools often are not gonna see this as a malicious operation, because you are just manipulating files, right? And that's a common thing to do. So it doesn't seem like you're doing anything wrong. So maybe at the statical level, what you can do is just when you're designing your code, you need to think about if you are elevating privileges and writing into these file or folders that could be accessed by lower tier users or processes. So maybe we can take a different approach, which is dynamic binary instrumentation. So, well, dynamic binary instrumentation is simply just a way to inject code and modify the process that is running without having to have access to the source code, without having to recompiling. You don't have to do anything to prepare that new binary. You just need your framework for instrumenting and hooking. And this is used for different use cases, right? Like testing. Sometimes as a programmer, you want to profile your system and see how many times you're making a syscall to see if it's doing more, or is spending a lot of computer power and something you don't want to. So it's a lot used for profiling, but for our case, we're going to use it for hacking. So in my case, I propose to use Microsoft Detours, which is an open source tool. It's well maintained, and it's written in C++, but you are free to use any other instrumentation framework like Frida or any other one. The reason I picked this one is because I want to maintain it as native as possible and as minimalist as possible. So that means I'm trying to use what is meant to be used for those kind of systems. So sometimes Frida is kind of complicated because it has a lot of libraries because you can use it in iOS, in Android, Linux. So that's the reason why I picked Microsoft Detours, and it's well maintained and it has a great documentation. So when you're making a call in your code, this is how a search function calls your target function. So the caller calls the callee function, and after it executes, it returns to the search function, and the program continues as normal. However, when you have a program that is being detoured or instrumented, you're going to have some intermediate functions. And the one we care about is the detour function. And as you can see in the image, there's you can modify or inspect the variables at the input, but also at the output. So you can call the target function with different parameters that you modify before they're called, or you can modify the return of the function and then have a different result from what is expected. And it's fairly easy to install. So this is it's made for Windows systems. You can use VC package, which if you're a programmer, you know that is like a tool that allows you to keep and maintain your libraries and add them, install them, have a good a good versioning of the library you're using. Also, we're going to use Shell Windows API because we're going to operate a lot with, of course, file names, path names, locations. So we need that to operate with the paths. And finally, just put wherever you install Detours there, you put it in your libraries. And my recommendation is that you compile statically so you don't have any issues with that. And it has a lot of different features, this framework. I'm going to show you the most essential ones in this slide. So the first one is that you need to define your transaction. And that's you can think it as any kind of transaction. You just put where it starts and where it ends and what you want to do in between. The second thing is that you want to update where the pointers and the addresses of those locations are. And so that's just something you almost mandatory need to do. And finally, you just put where the function you want to instrument and where it's going to be pointed to. And that's it. That's pretty much all you need. And this is, of course, a DLL. This is the easiest way to do it, but not the only one. You can create a driver. So if you want to, for example, monitor drivers or protected processes, you're going to need a different approach. But this is the most, or the easiest way to use it. So that's why I want to show this. And then this is what the logic of what I was trying to do looks like. So first, I want to define the security identifiers of the users that shouldn't be able to execute privileged processes. And then create a detour function for whatever I want to look into. In my case, since I wanted to follow that same approach of antiviruses, well, I'm going to look into any operations into files. Then we're going to look into the integrity level of the process. So if it's less than medium or equal, then if that's the case, then we don't care because that's not a high privilege process. We don't want to know whatever it's doing because it doesn't help us to leverage for privilege escalation. So, but if that's not the case and it's a high privilege process, then we can continue and look into the syscall that is making. In this case, we're looking into anything related to create files. As an option, you can filter out by operation. So based on the flags you receive, you can monitor by create file, remove file, delete file, because sometimes most of the functions that are in charge of operating with files, you just use one single function to do all these operations, and then depending on the flags that you pass, the operation is going to be different. And finally, we look into the ACL, and the ACL of the file, or whatever is going to be accessed, and if that can be accessed through any of our SIDs that we previously defined, then we log it into ETW, that I'm going to talk about it later. And if not, then that's not exploitable, and then we just return to the target function. So this is an example how I define the security identifiers. So security identifiers are like these strings that tells you what type of access each user on your system has. So I try to make it as general as possible. And this is not the exhaustive list. This is just to make it fit on the slide. But you can look into all in the Windows documentation, all the different access and all the different security identifiers that are predefined. Of course, there are many others, and you can also define yours. But at least I wanted to look at the most generic ones that have low privilege. Then it's very important that you want to reverse engineer the function that you are trying to instrument, because as you will see, when you want to catch the function and instrument it, you're gonna need the symbol. So some programmers remove the symbols, and some of the symbols that are almost always going to be there are the syscalls, yeah, right? Because you need a syscall to make it call on the operating system. So if you look inside of, in this case, create file W, which is a Windows API, you're going to see that it's a wrapper inside of another wrapper inside of another wrapper that at the end of the day, it calls empty-create file. And if you look into most of the file operations, they're all based on empty-create file. So it just depends on what flags you pass to it. They're gonna make a different operation, but also overwriting and deleting are based on empty-create file. So Detours has also this feature in which you can find easily where your library is. You just specify in which DLL you are looking into, and then you define the name of the function that you're looking into. And of course, the function pointer needs to include all the parameters as they are defined in the Windows documentation, or by reverse engineering if that API is not documented. And then the next step is just implementing the logic that I just described. So first is, that's the function that is altered, it's like the hooked empty-create file, so it's a modified version of empty-create file. So in this case, we're getting the token of the integrity level, and then we're trying to see if that, that token is greater than medium. So if it is not, we just return to the actual empty-create file, and we don't care about it. But if not, we're going to see if that can be accessed by any of the security identifiers that we previously defined. And in this case, I am filtering it by the operation type, which is create, override, or override if it already exists. And then afterwards, if all those conditions happen, we log it using ETW. And we put everything together into a DLL, which is a pretty simple DLL, nothing fancy. And you need, if you want to exit clean, you just need to, after detaching, you just, again, use the transaction to detach from the process, and that's it. So again, we're trying to rely everything on native tools, everything that is already installed. So you want to avoid to install as many other libraries as possible, so you don't need to deal with, because the idea here is, of course, this kind of test needs to be done not on production, right? This is always in test environments. But again, you need to do it, you want to do it as general as possible. So we want to rely on tools that your system already has. So ETW is like an event tracer for Windows that is logging all the things that happen on your system. Everything that is reported on Windows is going to be logged through ETW. So you can use it. And there are two great features about it. So the first one is that it's very efficient. It's going to write it in a temporary buffer in memory. And it's going to be predefined when it wants to write into a disk, so you get the result of the file. So you can define it either by size, minimum number of bytes, maximum number of bytes, or in our case, time. So we wanted to let it run this on engineering workstations that had different systems running for 7 days. And then after 7 days, look into the results and see if we catch something. So we catch different things, but we saw that one of them was constantly repeating, and we wanted to see what's in there. So it looks like this came from an operation from Iconic Suit, which is a critical SCADA by Mitsubishi. It is present in more than 100 countries. And by the way, thank you, Mitsubishi, for working with us, because they responded timely when showing this kind of issues that we found. But this system is widely used. Actually, it was presented here during Pound to Own a couple of years ago. So they were part of the program for vulnerability for bug bounty. And then, well, yeah, it's present in different places and in different systems. So we were able to exploit it, different vulnerabilities, as I first explained that DLL hijacking is the most common one. So we found a bunch of them. And what we were able to do was to execute or elevate privilege and execute code to interact with Modbus processes and making the EDRs think that this operation came from Iconics and not from a malicious user. So that is used to bypass EDRs or bypass alerts. But at the same time, want to show like something more like juicy. And we found that there was a way to, like following this same idea, how we can hijack the log file for this pager system to compromise the system. So here you can see a video in which first, local user with no privilege. This is manually, but this can be done automatically. But first, the local user is targeting where is that log file located, because this pager CFG, as its name implies, it's used to send messages when a PLC sends an alert. It can be done through a push notification in the application, or it can be done through a SMS server. So it's going to send a text or a push depending on how it's configured. So here, the attacker is creating a symlink, and this symlink is based on the object manager, so you don't need any like privilege on the system, you just like local user. And then he's pointing the file, the temporary file, to a kernel driver. In this case, CNG, and CNG is used for different things related to encryption and cryptography. So if we corrupt that system, when pager CFG makes a call, in this case, we are forcing it to send a message, but this can be also configured to whenever a PLC fails or whatever parameter that you define to send the message is gonna trigger this action. So in this case, we are forcing it to send the message. And as you can see, like the administrator doesn't seem like the path has changed. It's exactly the same. We send the message, but when we go and see what happened to that driver, and remember, this is a privileged account now, you see that cng.sys has been modified in system32. So the local account, of course, does not have access to that. You see cng.sys is now 1 kilobyte or less. And when we open it in a hex viewer, you're going to see that it's full with random, right? Connection closed. So it's because we don't have the SMS server configured. But it is filled with a bunch of stuff. So now the driver is corrupted. And when the administrator restarts or turns off or wherever, they just log off from that session, it never is going to come up again. So now it's restarting. This is running a virtual machine, but you're going to see that it never going to be up again. So it's corrupted, and if you are like the technician are trying to understand what happened there, we don't know, right? And even if you will need to do a lot of things to debug where the corrupted driver is, and then you will need to remove it or restore it. And as you might saw, like previously, a famous CDR corrupted a driver, and it was very difficult to recover from that. So of course, when we are in critical infrastructure, we are talking about the CIA triad becomes IAC, which is, of course, safety on top, but in operation-wise, we're looking into availability. So this creates a denial of service state, and yeah, imagine you cannot understand what is happening and what make it trigger this condition. So summarizing this is the overall diagram, how it looks. So we first used Detours or any other hooking framework to instrument all the processes in the system, and then define a condition for ETL or ETW to create ETL logs after a certain condition happened. And after some time, we were going to review using an ETW viewer of your preference the results. And in this case, we use two different exploitation attack vectors. So first, we were able to disguise or malicious code to execute something interacting with PLCs. But EDRs and other security contrameasures are going to think that this process or this operation comes from the Iconics suite and not from the malicious code. And the second one is that we created a symlink based on the object manager, which does not require any higher privilege, and then we were able to consider denial of service. And then from there, we just had fun, no profit. And soon we're gonna publish this blog. All those vulnerabilities are public and patched, but we're gonna have some blogs to cover more details about it, and we're gonna have also maybe other vulnerabilities disclosed as well. So thank you, and if you have